Hi, welcome to Math with Patrick. Today is January 19th, and we're solving the 19th problem from this Daily Epsilon calendar. All right, let's try it out. Each edge of a cube is increased by 6%. The volume is thus increased by X%, and I'm supposed to round my answer. Okay, like all the other problems, the answer is just today's date, so it looks like the final answer will be 19%, or I guess around 19%, because it does tell me to round my final answer. Let's start off with what increased by 6% means. If I take some amount, and I'll just do a length for right now. Let's say the amount is 100, and I increase it by 6%. It means that I should take my original amount, so I need all this 100, and I will tack on just a little bit more. And this part will be 6% of my original, or 6% of 100. A quick way to do some math to figure out what a percentage of something else is to multiply. Like, for example, if I told you 50% of 4 is ... you could do 50% times 4 and figure out what that is. Now, it's a little bit hard, in my opinion, to deal with percentages and do math with them. But what you could do is change it to a fraction. 50% is just 50 out of 100. If you simplify, it's just half, and half of 4 is 2. So, I mean, that was kind of an obvious example. I'm sure most folks watching know that 50% of 4 is 2. But this was just to show you that if you ever see percent of, you could convert the number and use multiplication. 6% of 100, I'll call that 6 over 100. That is 6% of 100. And at least in this example, it's pretty easy to see that these 100s cancel. So 6% of 100 is 6. And if I'm increasing it by 6%, that's where I'm taking everything that I used to have and tacking on a little bit more. So if I increase 100 by 6%, I will get 106. So say I wanted to increase some side, I'll say S for side right now, by 6%. The steps to do that would be, first, find 6% of S, and that looks like doing 6 over 100, multiplying it by S. And then step 2 would be add that onto the value of S already. Add that onto S. And so step 2 would be taking this amount and then adding it back to what I had at the start. And this two-step process of finding the small amount and tacking it onto the original totally works, but I could condense this down into one step. And a quick math trick is that if I'm increasing something by 6%, that's the same as multiplying by 1.06. And the reason why this 1 is coming up, I like to think of this 1 as the whole part that I had originally, and this decimal part is helping me increase it by just a little bit more. To prove this with algebra, I could factor an S from both of these, and so I get 6 over 100 plus a 1. You can kind of see how this 1 is coming from that whole part, all of this value of S that I started with. And if we simplify this fraction over here, I guess I could find a common denominator and add my numerators, and I'm getting 106 over 100 times S, my original amount. This number right here is 1.06. So instead of having to think about this two-step process of finding a little amount and then adding it to my original, to increase something by 6%, the quick way to do it is just multiply by 1 point and then the decimal version of your percentage. And 6% is the same as 0.06. Now I want to compare two cubes. I want to compare the original and then the one that I increased by 6% on all the edges. I guess I can label all of my sides as that length of S for this first cube. So the width and the length and the height are all S. They're the same number. If I wanted to find the volume of this cube, I'll do length times width times height, but they're all the same value. So it's S times S times S. That's the same as S cubed. Now, if I increase each side by 6%, like I was mentioning earlier, I could do that in just one step by multiplying all of these sides by 1.06. So now the width is 1.06 s, the length is 1.06 s, and then the height is also 1.06 s. So now I've increased each edge length by 6%. If I wanted to find the volume of this, it's still length times width times height, but I'm including this 1.06 on all three of my dimensions. So when I multiply this out and I cube it, I'm going to get 1.06 cubed times s cubed for this new volume. I guess I should differentiate between these two. I'll say volume initial and then volume final after I apply that transformation of scaling it up by 6%. So each edge goes up by 6%, but I don't yet know the percent increase for the volume. It's a little bit unclear, especially when I haven't done the math right here. So let's just do a little bit of decimal multiplication and figure out what I can rename this number to. If I do 1.06 times 1.06, I know that I can kind of think about it as just 106 times 106. And well, let's just run through the multiplication real quick. 6 times 6 is 36. 6 times 0 is 0, but I need to add that 3. 6 times 1 is 6. Here's a placeholder 0, but then I'm multiplying everything by this middle 0, so I actually don't really get anything in this row. Finally, I need 2 placeholder zeros because I'm multiplying the 100 part to this 106. And 1 times all of these numbers is fairly easy. I just need to be a little bit careful and make sure that my columns are all lined up. Okay, now it's time to add. Here's a 6, here's a 3, here's a 12, so I'll carry the 1. Wait, no, I don't have to do that. I was mentioning I have to be really careful about those columns, and I almost messed up. I carry the 1 here, 1 plus 0 is 1, and then here's that final 1. Now, I was multiplying 1.06 times itself, not 106 times itself, so I do need to place a decimal point somewhere. And I know that 1 times 1 is about 1, so 1.06 times itself is still going to be really, really close to 1. I could also show that the decimal point should go here because I originally moved it right 4 whole spots. And so to compensate in the end, I'm moving it left 1, 2, 3, 4 spots. So I'm convinced that 1.06 times itself gives me this number. And I need to do it one more time because it was cubed. I'm multiplying 1.06 to itself 3 times over. So let me do 1, 1, 2, 3, 6 times 106. Again, it's a little bit easier to think of this long multiplication with whole numbers, and I'll just place this decimal point right after the leading 1 of my final answer. I just know that, something really close to 1 times itself over and over again is not really going to increase its value that fast, that quickly. So time for some multiplication. 6 times 6 is 36 still. 6 times 3 is 18, plus this 3 is 21. 6 times 2 is 12, plus 2 is 14. 6 times 1 plus 1 is 7. 6 times 1 is 6. Here's another placeholder 0, but I don't really have a tens place, so this row, this number doesn't exist. Finally, kind of like before, I'll have these 2 placeholder zeros for my 100 that I'm multiplying, and then 1 times all of this will just be the same digits that I see up top. Cool. Let's add it all up. 6, 1, here's a 10, I'll carry this one. That's an 11, so I'll carry another one. This makes a 9, and these 2 ones just come down. Cool. So I get this number when I do 1.06 cubed. All right, let me clean this up a little bit. So from multiplying 1.06 to itself 3 times over, or cubing it, I got 1.191016. Okay, so I could put that in place of 1.06 cubed. 1.191016 times s cubed. Now I can compare the original volume to my final volume a little bit more easily. It looks like I'm scaling it up by this number right here. But remember earlier how I said a 6% increase is the same as multiplying by 1.06? So now we're just thinking about that, but the other way. If I'm multiplying by 1.191016 and going backwards that way, I'm taking this amount right here and calling it a percentage. So this is a 19.1016% increase. All right, and I'm rounding here, and it was a little ambiguous where I should round initially, but it probably means round to the nearest whole number. Between 19% and 20%, these are the two whole numbers on either side of this number, I'm going to choose the 19. That's just because ones tell you to round down. They're just super close to the lower number, and I'm rounding down to that 19. Well, what do you know? 19% is the answer. Here is the 19 from today's date, and we're all done. Well, thanks for coming along, solving this problem with me. We did a little bit of geometry, a little bit of work with scale factors, and seeing how the linear scale factor affects the cubic scale factor here. And of course, there's a lot of long multiplication too to really work through those numbers and figure out how to get this number. So thanks again. We're all done for today, and I'll see you tomorrow. Bye.